Good morning, my dear students. My name is Dr. KCH Apparao, working as a associate professor in mechanical engineering department. Today we'll see definition and terminology of dimension analysis. Dimensional analysis mainly used in the convection processes to solve the problems in convection processes. First of all, we'll see what is convection. What are the types of the convection? So convection, already we discussed this one. Convection occurs only in fluids because in convection occurs due to bulk movement of the particles. Without movement of particle, there is no convection. Convection takes place from either solid to fluid or fluid to fluid. Okay. So convections are two types. One is natural convection. Second one is the forced convection. Natural convection means it occurs due to buoyancy effect. You know this one. This is the container. Water is here. If you give heat to this container, so the particles which are very near to this surface, first of all, the bottom surface of the container will be heated. Then the particles which are very near to the bottom surface, those particles will be heated. So when the particles are heated, the density of those particles will be decreased because density is in direct proportional to temperature. You know this one. This less density particles moves into upward direction. Heavy density particles moves into downward direction. In this way, heat transfer takes place from the solid to fluid. So here particles movements occurs due to the effect of buoyancy, occurs naturally. So this type of process is called natural convection. We already discussed it. So next one is the forced convection. Forced convection. Forced convection. Here also movement of the particles, bulk movement of the particle should be needed. So this is the surface. So on this surface, fluid is flowing like this one. For the movement of the fluids, here we'll use some external agent. It means so here fluid motion is artificially created by means of some external force, some external agent. So due to some external agent, this fluid moves on the surface or moves in the any pipe or something. So here heat transfer takes place from the solid to fluid. This is the surface Ts. Fluid temperature is equal to Tf. Okay. If the Ts is greater than the Tf, heat transfer takes place from the solid to fluid. If Tf is greater than the Ts, then heat transfer takes place from the fluid to solid. So type of convection is depend upon the movement of bulk movement of the particles. In some cases, particles move naturally by the effect of buoyancy. In some cases, fluid particles move by some external agent. So artificially movement of the particles, fluid particles. Those are called forced convection. So this is uh, regarding the convection. In convection, it means fluid motion. For the study of the fluid motions, uh, we have to consider all the properties of fluid. Fluid has many properties like density, viscosity, kinematic viscosity, and surface tension, and heat transfer coefficient. Many parameters are there. So study of each parameter on a particular work or particular system is very critical. So consideration of all the effect of these parameters or these properties on a system and the convection process. So that one also very critical. So for this one, to solve the this problem and to study the convection process, we'll use some method that is called dimensional analysis. By the help of the dimensional analysis, just we convert the all these properties into some dimensionless members. So we'll see what is the dimensional analysis. So dimensional analysis is the mathematical method in which physical quantities are expressed in terms of the fundamental dimensions. Fundamental dimensions, so it means uh, so basic fundamental dimensions of any characteristic is the mass or length or time, sometime temperature also. Okay, so it is a mathematical method in which physical quantities are expressed in terms of their fundamental dimensions. Okay, so such method, this type of method is known as the principle of dimensional analysis. We'll see how to uh, formate these physical quantities or dimensional terms. We'll see. We know this one. Particularly the heat loss by convection is extremely complex process, because convection process is the extremely complex process, because the fluid has many variables. The controlling variables are numerous, so it is difficult to study the effect of each variable in this process. Okay, so because effect of density, effect of viscosity, effect of kinematic viscosity, effect of heat transfer coefficient, effect of surface tension, effect of velocity, acceleration, and everything. Velocity, so many parameters are there. So it is very difficult to study the effect of each variable in this process. Okay, for this one, so dimensional analysis is helpful. So it is possible to investigate experimentally and express scientifically the result for any geometrical configuration using the dimensional analysis. That is the main purpose of the dimensional analysis. The major advantage of dimensional analysis is to reduce the number of variables in a problem with the help of the dimensional analysis. So we can combine the variables of the problem to dimensionless groups. Dimensionless groups, just like some groups of Prandtl number, Nusselt number, or Reynolds number. So we are converting uh, these parameters, these variables into some dimensionless numbers. Okay. So by studying these dimensionless numbers, we can understand the functioning of convection process. So this is the main advantage of the dimensionless analysis. Okay. So how to do the dimensional analysis? So here some methods are there, some theorems are there, in which we'll see first of all Buckingham pi theorem. So we'll see what is the definition of Buckingham pi theorem. So Buckingham pi theorem states that if there are n variables in dimensionally homogeneous equation, and if these contains m fundamental dimensions, variables are n variables in which fundamental dimension, just like mass, time, what is the, so temperature also if you consider, time, length also. So these are the fundamental dimensions. So if this contains some fundamental dimensions, then the variables are arranged into n minus 1 dimensionless terms. So according to pi theorem, Buckingham pi theorem, terms is equal to pi terms. These are called pi 1 is equal to. So total number of pi terms, pi 1 and pi 2 and pi 3. See, this number is equal to n minus m. Okay. So we'll see just like if a problem involves n relevant variables and m independent dimensions, then it reduces the relationship between the n minus m. So these are the non-dimensional parameters. So suppose n minus m is equal to 3, then we will see pi 1, pi 2 and pi 3. So these are the dimensionless parameters. Okay. So to construct these non-dimensional pi groups, first of all choose m repeating variables. What are the repeated variables? Based on geometry, based on the velocity, based on the flow. Okay, we have to identify the repeating variables. For each of the n minus 1 remaining variables, so construct a non-dimensional pi terms. So it means we will take one variable. So this one is the repeating variables, scale 1, scale 2, scale 3. In every pi term, these are the repeating variables. We take the repeating variables, and in every condition, variables will be changed. Okay. So here, where A, B, C are the chosen as to make the each non-number. For the solving purpose, we are just taking the A, B, C are the powers. Okay. So these are the uh, dimensional analysis, importance of dimensional analysis. Okay. Uh, by the help of the dimensional analysis, we can change the variables which are in convection into some dimensionless numbers. Those dimensionless numbers, such as Reynolds number, Prandtl number, and Grashof number, different numbers are there. We'll see first of all what is Reynolds number, what is the importance of the Reynolds number. So we'll see. So it is the ratio of inertia force to viscous force and the velocity boundary layer. Okay. So it is the inertia force. It is the ratio of inertia force to viscous force. We'll see this formula also. Inertia force is equal to rho ul. Okay. Rho u is the velocity of the fluid. LC is the characteristic length. Okay. So rho ul by mu. You know this density by mu is equal to nu. Mu by rho is equal to nu. Kinematic viscosity. So dynamic viscosity by density is equal to kinematic viscosity. You know this one. You can. This is the formula for the Reynolds number. Okay. So these are the just like variables which are related to convection process of fluids. So velocity of the fluid, characteristic length of the material, and just kinematic viscosity of the fluid. Okay. So characteristic length of the flow geometry. So next U alpha is the steam velocity of the fluid density, and dynamic viscosity of the fluid, that is the mu. Mu is the kinematic viscosity of the fluids. You know all these parameters. So if you study the uh, Reynolds number means, so we are considering all these parameters. Okay. Uh, so by using this Reynolds number, we can identify which type of flow, either laminar flow or turbulent flow. By using the range of this Reynolds number, you can identify the type of the flow. So that is the dimensionless number used to study the convection process. So we'll see one more dimensional number, that is the Prandtl number. So Prandtl number defined as it is the ratio of momentum diffusivity to thermal diffusivity. Momentum diffusivity to thermal diffusivity. So this is the formula. So Prandtl number PR is represented by PR. RE, that is the Reynolds number. PR is the representation of Prandtl number. So PR is equal to momentum diffusivity by thermal diffusivity. So momentum diffusivity, that is nu by alpha. You know that alpha is the thermal diffusivity. Already we discussed in previous classes also. That is the K by rho Cp. So this one. So you can take the momentum diffusivity. Momentum diffusivity is equal to mu by rho. Mu by. So this is the rho, kinematic viscosity, nothing but. So mu by rho by, so thermal diffusivity is equal to K by rho Cp. Okay. So rho cancel and mu Cp by K. So this is the Prandtl number value. Okay, mu Cp by K. So this is the dimensional number. So by multiplying this one, so values should not be changed. So that is the, because dimension, these parameters are these numbers have dimension, doesn't have dimensions. So it is a dimensionless property. What is this one? Prandtl number is a dimensionless property, a function of temperature. So it provides a measure of relative effectiveness of momentum and energy transfer in the velocity and thermal boundary layers. So it is used to explain the conditions of thermal velocity boundary layer and thermal boundary layers. Okay. So regarding the energy transfer of velocity and thermal boundary layers. So this is one of the dimensionless number, a Prandtl number, used to study the convection process. We'll see one more thing. This one is the Grashof number. Grashof number is mainly used to study the natural convection process. Reynolds number mainly used to forced convection process. You know this one. So what is Grashof number? So Grashof number is defined as the ratio of buoyancy forces to viscous forces. Buoyancy forces by viscous force. So it is used to mainly in free convections. So buoyancy, because particles move from bottom to top by the effect of buoyancy forces. So here it includes only buoyancy forces, doesn't include the velocity of the fluid. But in case of Reynolds number, RE UL by nu. So this is the velocity of the fluid. So velocity occurs only in the forced convection. Okay, so we'll see the formula for Grashof number. So Grashof number is equal to buoyancy forces by viscous forces. The formula of this one. So the finally Grashof number is equal to, so G, acceleration due to gravity. The beta is nothing but 1 by T mean. 1 by T mean. So T mean, that should be in Kelvin. K. So delta T, temperature difference. LC is the characteristic length by kinematic viscosity square. So this is the formula. So by using just all these parameters, all these variables which are affecting the convection process are converted into Grashof number. By studying this Grashof number, you can understand the uh, uh, just condition of the convection process. Okay. So G is the acceleration due to gravity. Beta is the coefficient of a volumetric expression. T mean is the temperature difference. You know this one. Nu is the kinematic viscosity. So this is mainly used to study the natural convection. So next one is the this is the this shows the importance of characteristic length. Characteristic length is depend upon the um, geometrical body, either it is cylindrical form, spherical form, or a horizontal form, anything. So next one is the Nusselt number. Nusselt number, it includes in natural convection and forced convection also. So it is helpful to study the natural convection process and forced convection process both. It is defined as the convection heat flux to conduction heat flux. Convection heat flux, that is related to H, and conduction heat flux, that is related to K. Okay. So convection by conduction. Convection is equal to HA delta T by convection. Convection by conduction. Conduction is equal to K into delta T. So by dx. So this is the formula we will see here. Nusselt number. So this one is the Nusselt number Nu, represented by Nu. Nu is equal to convection heat flux by conduction heat flux. You know that area both are same. Area will be cancelled. So H into delta T, heat transfer coefficient into temperature difference by so here K delta T by LC, characteristic length, should be considered here. So the finally delta T will be cancelled. The formula for the Nusselt number is equal to HLC by K. So LC is the very important parameter, that is the characteristic length. It is depend upon the geometry of the body, what type of body you are, or what type of uh, construction has been taken or will be taken. So to flow the fluid. So solid body either may be cylindrical form or spherical form or just like any rectangular form also. So LC is the characteristic length of the fluid flow. K is the thermal conductivity. All these parameters. It means by using this Reynolds number, Prandtl number, and Grashof number, and Nusselt number. So by using these parameters, we can understand the system of convection process or convection process phenomena. Okay. So one more thing is the just Stanton number. It is the ratio of Nusselt number to Reynolds number. Nu by Re, just is. Okay. It is related to just like both Nusselt and Reynolds number. So these are the numbers, important numbers, Reynolds numbers, which are formed by dimensional analysis to study the convection process. Those are Reynolds number and Prandtl number, and next one is the Grashof number and Nusselt number. Okay. So Reynolds number, Prandtl number, uh, Nusselt number. These three for the study of forced convection. Grashof number, Prandtl number, Nusselt number. These three for the study of the natural convection. It means so Prandtl number, Nusselt number, both are used to study the natural convection and forced convection. Okay, but RE related to forced convection. Grashof number mainly used in the study of natural convection process. Okay, so these are the things, the importance of dimensional analysis and the importance of these dimensionless numbers. Okay, so next we'll see boundary layers. So define the boundary layer thickness. Boundary layer thickness. So this is the definition. The thickness of the boundary layer has been defined as the distance from the surface. Distance from the surface at which local velocity or temperature reaches 99 degrees of external velocity or temperature. So you'll see here, you can understand. This is the velocity profile. Initial velocity. So this is the stream. This is the solid surface. Fluid is flowing on the solid surface. Here, this one is the velocity profile. Initial, the velocity of the particles which are very near to solid, very less, 0. So then gradually velocity will be increases. So at particular position, the velocity is very near to equal to stream velocity, u alpha. So here the velocity is equal to u alpha, not completely equal. It means 99% of equality we can see here. So that position from these positions to surface. So this distance is nothing but that is the boundary layer thickness. Okay, it is represented by delta. So this one is the boundary layer thickness. The boundary layer thickness, the distance from the surface of the body up to the point where the local velocity reaches 99% of u alpha. So it should not be equal, but it is very near. That is 99% of the free stream velocity. So from that point to 99% of u alpha point to up to surface, this distance is nothing but boundary line thickness. Okay, so this condition will see either in velocity boundary layer or temperature thermal boundary layer condition also. Same here, just like thermal boundary layer. So this is the profile of the thermal temperature profile. So at solid surface, the temperature is very high. So this temperature curve gradually decreases. Okay. So at particular point, this temperature is equal to fluid temperature. It means T alpha. Not equal completely, 99% of the T alpha. So fluid temperature, it reaches to fluid temperature. So that point to, so the distance from that point to surface. So that is called, this one is the thermal boundary layer, velocity boundary layer or thermal boundary layer. These two things you have to note at this one. Okay. So this one is just like different textbooks. You can refer these textbooks for proper understandings of terminology and definitions of this convection process, convection process and dimensional analysis, and what are the dimensionless numbers like Prandtl number, Reynolds number, and these numbers. So thank you for watching this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.